Hey everybody, if you're new here, my name is Jake, and today we are going to be making a security camera with AI. I did a video on this recently, so that's the part one. Go check that out if you haven't seen it. This is part two. We're going to be discussing how to do multiple cameras at once and also night vision or infrared, that kind of thing, how we can achieve it. So to get started with that, we're going to take a look at our new technology, our new hardware that we're looking at. We are using Raspberry Pi Zeros. These are kind of like the stripped down version of the Raspberry Pi, and that's going to be doing our computing for us. And then the two cameras I'm going to be testing, the Starvis IMX462. This is a ultra low light camera, so it's just meant to be used in outdoor environments where there's not a lot of light for you. So, and then additionally, I have the Noir IMX2019. This is like the cheapest infrared camera I could find. It was like 18 bucks. The Starvis was like 60, so that was a little bit more expensive, but it was like one of the nicer low light cameras I could find. And then this is just an IR illuminator that I got off Amazon. So basically how we're gonna run this setup is slightly different than how we did it last time. Previously we had the Oak One camera that was hooked up to our Raspberry Pi, and then the model was running on the camera. In this setup, I took a slightly different approach, and we'll see the pros and cons of that, where the Raspberry Pis are attached to the cameras. The photos come in from the cameras. We send the photos back to the host machine, which in this case is my desktop. That runs the model on the images, and then that sends back to the Raspberry Pi whether it should begin recording. So if we have any detections, then we start recording onto the Raspberry Pis. Okay, let's jump into this. Okay, so here is the code that is run on the Raspberry Pi. Essentially, we're going to be using the PiCam2 library to interface with the camera. We set up a video configuration that both has a main stream that's at 720p and a low resolution stream at 640 by 480. The reason we do this is because the low res stream that comes from the camera is what's going to get sent back to the host machine for it to be run on the model to see if there's detections. And then if there are detections, then we'll take the main stream and use that higher resolution to record to disk. Feel free to make comments if you have any. I'm not a Python master, and I'm also new to these camera libraries, so there's probably better ways to do this. Okay, essentially we're running a WebSocket server on the Raspberry Pi Zero that just has a couple different endpoints that are accessible. The most obvious usable one is going to be toggle streaming. So when we send this message, we're just telling the Raspberry Pi to start emitting back those low resolution frames. And it starts this stream background task, which takes a photo from the low res stream, packages it up, and then emits it on the video frame event to any listeners. The other events we have are a start recording and a stop recording. If these events get received, then we'll start recording to disk. And that's pretty much all there is to the script that's running on the Raspberry Pi. So let's take a look at the script that's running back on the host machine, which is my desktop. So on the host machine, it's slightly different. We're going to load in YOLO V5, which will be the pre-trained model we'll be running on the low resolution frames we get back. We filtered the classes to only ones we're interested in. So this is like cars, people, trucks, things like that. So again, this is another WebSocket. This is a client, since this is going to be reaching out to the Raspberry Pis. And essentially what this does is listens for the video frame event from the client or the Raspberry Pi Zero. And when the video frame event is triggered, we take the data from the photo, we add it to the frames to display list. And this background job goes through all of the frames in the frame to display list, and it runs the detection. It looks for detections using the YOLO V5 network. And concerning the buffer system that I had in the previous video, I think I've kind of made, I don't know if it's better, but it's a little bit more elegant looking of a solution. Instead of counting frames, what I'm doing here is that if we do have detections, I emit the start recording event to the Raspberry Pi Zero, and then I set a timer so that after 5 seconds, we emit the stop recording event. All this does is emit stop recording. Okay, so every time we have a detection, the timer gets reset. So this is kind of achieving the same thing that the previous buffer system did, and it's just a little bit nicer looking. So there's that. Okay, so that's pretty much all the code. Let's take a look at what this actually looks like. Okay, on the left is my iPhone, just as a sample, and the right is the infrared with no light. Now on the left is the low light, and the right is the infrared with the infrared light on. As you can see, it's pretty impressive. The low light seems to work really well. Here's my front yard with the iPhone and then the low light camera. Again, really great performance from the low light and a lot of good detections. Has no problem seeing me. However, the infrared with the IR light really struggles. It can't even identify my car. It seems to see me pretty well when I walk in front of it, but this might be just a case of the light not being bright enough. Okay, so final thoughts. What do we think about all of this? So first of all, I was really impressed with the low light camera. As you can see from these clips, it just is really good definition. It also looks great during the day as well. And it had a wide angle lens. It was obviously more expensive, but I still really think it's a great product. The infrared camera, I gotta say I was a little disappointed in. Granted, I did buy like the cheapest one. I bought like the $15 one and it didn't have like a wide angle. Additionally, I also kind of cheaped out on the light. I got a pretty small light, especially considering my front yard's pretty large. From where the camera is sitting to the end of this street that I'm walking is like at least 50, 80 feet. Even though the light box says that it can illuminate up to 80 feet, I think if you want to like really strongly cover an area, you'd need multiple and stronger lights. So I would say that if you wanted to implement an IR, maybe inside or like in a small dark room, then it might work a lot better. If you want to illuminate a large outdoor area, it's going to be a little bit more cumbersome, especially if you want to get like a high quality image, because even this is very dark. That being said, the low light cameras were more expensive, but I think I got more utility out of it since it can be used in the day and at night, and the image quality is just really impressive. As you can see, it was very dark in my backyard. Like that iPhone photo is pretty realistic to how dark it felt, but this low light camera illuminated everything. So very impressive. The other things that I would change about this setup is, obviously I mentioned before, we're running our detections on a host computer, which is my desktop. If we wanted to do this in real life, I would most likely run it on a Raspberry Pi with one of their AI hardware kits, I believe they're called, which adds processing power that allows them to run the model. So I would not have to run this on my host computer. Additionally, I'm using WebSockets to communicate between the Raspberry Pis and the host. This isn't really the fastest way to communicate, especially because we're passing image data, which can potentially be large, at a high rate, because we want to pass photos to the host so that they can be analyzed, and then we can send a response back. We're potentially doing this multiple times a second for multiple frames. You want to do it quickly. So not only is there a bottleneck with the detections running on YOLO, there's a bottleneck on how much data we can get over WebSockets from the Raspberry Pi to the host. I saw that PyCamera 2 library has a way to transfer data via UDP port. So I may look into that and see if that's a more efficient way to do it, especially because I'm just working in my local network. So I'm not a huge networking person. I'm going to have to look into that and see if there could be a better, if that could be more efficient. Aside from that, I thought this was a really cool project. I like the low light camera. I think the IR light could be useful in some situations. And I think the next thing I want to take a look at is how I can take this data and conditionally put it in the cloud so that I can view it anywhere that I'm at. So if I'm at a friend's house, or I want to check to see if a package has been dropped off, I want to be able to remotely activate one of these cameras and view it from my phone, and then potentially have that data deleted afterwards and cleaned up. So I guess that will be in the next video. But thanks for watching. See you later.